So we are going to be talking about when a is not equal to 1. So what that means is there is a number other than 1 in our first term with our x squared. Solving questions like this are tricky. In order to get a number there, that means our set of brackets is going to potentially have a number in front of our x term. So it could be something like this. In this example, both signs are plus signs. So it's going to be 2 plus signs here. So we have some blanks to fill in. I should have added initially, there's not a greatest common factor. There's not a single number that goes into both 2, 7, and 3. What's lovely about this example in particular, the only way I can multiply to 3 is using a 3 and a 1. Do you guys agree with that? Yes. So let's fill that in. The only way I can multiply to 2 is using a 2 and a 1. But where should I put the 2? So the 2 can go in the first spot or the second spot. We have to add to 7. So this is why I say in my instructions here, find the factors of a and c. That's what we just did. Then use some logical trial and error. We have to get values after we do our multiplying that are going to add to 7. Charlotte. Good. So we're going to put our 1 here and our 2 here. The reason for that is I get, like if we do our FOIL, 1 times 2 gives us our 2x squared. And then we would do 1 times 1, which gives us, that's really messy. Let's try this again. If we actually went through FOIL, we would get 2x squared. 1 times 1 gives us plus an x. 3 times 2, we needed that to happen to give us 6x. So that way we can combine these to get to 7x's plus our 3. So you have to be really strong with being able to multiply your polynomials in order to do these ones. I find this is just a strategy. You do not have to do this, but it's a strategy that I have found to be very effective, is writing it out with those blanks. Because that way you're kind of prompted to fill in pieces as you go and it takes away some of the options. So for example, in this next one, the only way I can get to 2 is with using a 2 and a 1. The only way I can get to 3 is by using a 3 and a 1. When I say get to, I mean we're multiplying to get to those numbers. So my factors are going to be something x plus something times something x plus something. Again, I only have plus signs, so these are all going to be positives. So now I just fill in one of them. Completely random, it doesn't matter because my restrictions aren't at place. So I'm just going to put my 2 and 1 in. So this is a 2 and this is a 1. It gives me something to kind of fill in, which makes it easier to think this through. So now I need to place that 3 and 1. I need to place it so that way we can get answers that add to 5. If I put my 3 here, don't write this down, I get 2 times 3. That means I'm already at 6, so that's too big. So if I put the 3 here and my 1x here, sorry, I didn't write the x down. Oh, thank you. Now I get 3x squared plus or 3x plus 2x plus 2. So then these two add to our 5x's. Do you guys see how it really matters where those numbers go? If I put it in the other places, if I flip-flop 2 of them, it's no longer going to add to our 5x. Which then that makes it much, much more difficult to rearrange and find out kind of where you're going. Okay, so this next one, I have a 5 and a 1. The only way I can get to 1 is using 2 1s. The only way I can get to 5 is with using a 5 and a 1. 5 times 1 gives us 5. 1 times 1 gives us 1. 5 plus 1 is our beautiful 6. So in this one, we're going to get 5x plus 1 and x plus 1. What do you notice about all 3 of those examples, specifically looking only at our A's and C's? All of those A's and C's are what, Andy? They're all positive, yes. And what else? Krista, Carissa, sorry, Charlotte. Right on. They're all prime and they're all positive. For this level, so when we're talking about a not equaling 1, having a prime and positive for those two are as easy as they can get. Our options are significantly limited. So it made it a little bit easier to choose where our values are going to go and what values to use, right? We only had one combination for our two constants, and we only had one combination for our two coefficients. It was just which order do we place them. As we go through this, you're going to see you're going to have more and more options. I want you to try this next one here, just the first one on your own. So a question like this, again, I think it's really helpful to lay this out. That's our starting point. Only have two options for the 2, only have 2 options for the 5. Who wants to share? Did no one get it yet? Did I cut you off too soon? Okay, what'd you get, Tim?
10x squared plus 7 plus 1. I mean, for that it's 5x plus 1 and 2x plus 1.
Okay, so if we do like that?
Yes.
Okay, so if I do this, I would get 5x times 2x, that would give me 10x squared. Do I want 10x squared? No. Okay, Carissa. 1x plus 1 and 5x plus 2. So if I do it this way, let's check. 5x times 1x gives me 5x squared, so that's good. 5 times 1 gives us 5x. 2 times 1 gives us 2x. Those add to our 7x's, then I get 2 times 1. Is that okay? Does that make sense? How many of you got it? Good. Okay. This next one, it's a slight step more difficult. Is 6 a prime number? No. So that gives us, when we start off right away, we should be thinking of our answers for 6. So we could use 3 and 2 for 6 or 1 and 6. I strongly suggest you actually write these down. And then for the 2, we only can use 2 and 1. So in this one, if I start out, I would actually start out filling in the 2 and the 1. There's only one way that can go. So fill in your most limiting pieces. I have to have a 2 or a 1, so let's start there. Now I know I can either fill in the rest of this with 3s and 2s or a 1 and a 6. I have to multiply, so that way I get 2 numbers that add to 7 in the end. So right away, we should know we don't want a 6 in this spot because I'm going to get a 2 times 6, and that gives me 12. That's way too many. Right? So you can start thinking about pieces like this. I want you to try right now. Take a moment, see if you can fill it in. Okay, does anyone want to share? Go ahead, Matthew.
2x plus 3.
Good. This gives us 2 times 2, which gives us 4x's, and then plus 3x. That gives us our 7x. So that's why it has to be in that order. If you flipped your 3 and your 2, you're going to end up with 2 times 3, which gives us 6x, plus 2 more, too many x's. So with these questions, you should always know if you're right or wrong. It's hard to fill them in, but you should at least be able to recognize if you're unable to fill it in. Raise your hand if you got that one correct. Good. This is hard. I realize at the end of the day, all we're doing is multiplying, adding. Like the math piece behind it isn't actually that hard. Understanding it isn't that hard. But being able to fill it in is where it gets really tricky. Okay, this next one, 6 again, out front is not prime. Sorry, is prime. 3, whoa, words, I apologize. 6 is not prime, 3 is prime. So what that means is 3's are more limiting factor. So when I write down 3, I only can use 3 and 1. The 6, again, I can use 2 and 3 or 6 and 1. So when I fill this out, fill in your most limiting piece first. So I'm going to have something x plus 3, something x with a 1. Do we know where my plus sign goes? No. What do we know, though? For this to be a minus sign, 1 is going to be positive and 1 is going to be negative. We have to get all the way up to positive 17. So I need to have some big numbers there, right? 17's fairly big. We have 6's and 3's. That gives us 18. 18's pretty close to 17. So that's leading in that way. So when we do this one, I want a 6 times my 3. I need that answer to be positive. Then I need to get rid of 1 to bring me down to 17. So then I have to put my 1 here and make this a minus 1. Because that then gives us positive 18x minus an x, which gives us our 17x's.
When we're answering, do you want us to write out the full FOIL?
No, that's your check. For you to get a full credit answer here, all you would have to do is write that.
Okay.
That's it. I'm trying to give you as lot of strategies as I possibly can to help you fill some of these in. How is that? Somewhat okay? Okay. Before we go on to our kind of method 2, I want to give you guys some time to practice that one. Personally, and in the past, I'm going to give you guys a bit of a moment to understand something here. Traditionally, this is the only method we've taught. This method we really like because it builds stronger math students. It makes you work on your numeracy. It makes you work on your number fluency, which are really important skills for grade 11 and 12. We decided this year, because of COVID-19 and our pandemic and all the additional stresses you guys are under, some of your critical thinking skills are being affected by that, which makes your number fluency and your number sense not as strong as it normally is. And so we're going to teach you a second method that's steps 1 through 4, the same steps every time. Are those steps as helpful when you get to grade 11 and 12? No. It makes factoring take way longer. Are they always effective? Yes, but they're much more time consuming. So then next year when you're factoring is like the small part of the question, suddenly each question will take much longer. But we want to make sure you guys are understanding it and able to do it. So we will go and teach you the second method, which is called decomposition. This is the first year we've ever taught it, to give you some context. I know you guys keep picking on Camille, but a lot of tutors really teach decomp, and we don't love that. And we constantly are fighting with tutors about it because it's just our belief. Our belief is that it's not the best method because it doesn't teach you to understand why. It's just this process. So I want to give you guys, let's say this class ends at 2:25. So let's give you 20 minutes, so until 2, to work on some questions using this method. So the questions I want you to do are right here for you. And I want you to do, let's say, work on these first ones. So the first 9 questions I want you to do here. Just using this method, just so you can have some practice on your own. We will teach you this decomp method, but these are where I want you to start for right now.